Now let's try one last problem. We've got currently quarters have weights that are normally distributed with a mean of 5.670 and a standard deviation of 0.062 grams. If 280 quarters are inserted into the vending machine, what is the probability that the mean, keyword here, is you're finding a probability that the mean will fall between 5.55 and 5.79. So we'll start off drawing our standard normal curve. The two values we're going to be concerned with are the 5.55 and the 5.79. So here's our 5.55 and our 5.79. And we want them to fall between those two values. And now what? Now to find the area in between these two, we're going to use a normal CDF. Just like always. And we'll start out with our beginning value on the left of 5.55, comma, our area we want to stop it at 5.79, comma, the second to last thing that we always insert is our mean, which is 5.670, so we'll input that next. 5.670, comma, the next thing that we want to enter is the standard deviation. Well, remember, because we have means, you actually have to do a little bit of work here. To find the standard deviation for the means, you have to take the regular standard deviation and divide by the square root of n. Well, the regular standard deviation, according to this problem, is our 0.062. So 0.062 divided by the square root of n. Well, n is the number in the sample, which is 280, according to this problem. So we'll take our 0.062 divided by the square root of n, which is 280, and we'll take that whole value. We'll have our calculator do this for us, and we'll input it as our last part of our normal CDF. I'm running out of space, so I'm going to move it to the next line. 0.062 divided by the square root of 280. And then we'll close off our square root and close off our normal CDF, and we'll see what our calculator gets for us. What we get when we do this problem is we get something where we're getting 1, which means that this will definitely happen. So, as much as you can, use your calculator to do the heavy lifting for you. And again, how you know that these problems are different when you have to do this computation to find your standard deviation is when you're finding a probability for a mean. Not just one value, but a mean of several values. And that's why you end up with a sample size in your problem as well. But that's it. So your formula sheet for this test 3 for chapters 5 and 6, it's up to you what you want to put on it. Remember, it has to be one-sided and handwritten. I would highly recommend that you put some of the calculator stuff, especially if you have trouble remembering which buttons to press and when. Certainly, I would want to put this formula for standard deviation, maybe a note on when you use it, that sort of thing. Maybe the normal CDF as to write how that works. Also, just to give you a quick summary of what we've done here in Chapter 6, because it is a little bit confusing, let's take a look. So in Chapter 6, what we started off by doing is taking a z value and turning it into an area or a probability, and then you could turn it into a percentage if you needed to by multiplying it by 100. So you could convert it into a percentage if you needed to by multiplying by 100. And we did this using the normal CDF, and because we had z values, we only just needed a start and an end point. Then we also said you need to be able to do the reverse, is take an area or probability or percentage and turn it back into a z-value, which meant that we were going to do the reverse. We did an inverse norm function on our calculator, which, as a warning, needed an area to the left. And that's pretty much everything that we did here in 6.1. Then, in 6.2, we said, well, what if we don't have a z-value? And we have, let's say, a regular data value, an x value instead. Then we said, okay, that's fine too. We still want to do the same things, though. We need to find an area, probability, or you can still convert it to a percentage by multiplying by 100. We still did the same exact thing. We still did a normal CDF. We still did a start end and a stop value, but we added 2 extra pieces, a mean and a standard deviation. And still we wanted to be able to do the reverse, take an area, probability, or percentage and turn it back into just a regular data value, in which case we still use the inverse norm, and it still took an area to the left. But just like with the normal CDF, we had to give it 2 extra pieces of information, the mean and the standard deviation. Then that was what we did in 6.2. Then in 6.3, we took it one step further and said, well, what if we don't have an x, something kind of similar? We started talking about means. So that's why I'll put a bar on it. X bar means mean. We said we want to take that and turn it into an area or a probability or possibly even a percentage when you can multiply by 100. You still did a normal CDF. We still have a starting value. We still have an ending value. We still put in the regular mean next. It's just when we inputted the standard deviation that we had something special. We had to take the standard deviation and divide by the square root of the sample size for our means. And that was our extra special part of 6.4. And that was because we were talking about finding probabilities for means. And this little special piece of information came from our central limit theorem, CLT. We did not do the reverse, taking an area or probability and turning it back into a mean. So we didn't have to do an inverse norm for these. But that gives us a pretty good summary of what we did. Don't forget, we also mentioned something called critical values. And they look something like that, Z with a number on the bottom as like a subscript. So you might see something like Z of 0.01 was one that we did in the notes. And what that means is whatever number is down there, in this case 0.01, is that it's an area to your right. Critical values always give you the area to the right. I know that's not what we want, but it's what they're going to give you. So you used your area to the right, the 0.01, but in order to find the Z value that they're looking for, you need to do an inverse norm, which means you would need to find the area to the left, which is always going to be 1 minus whatever you had to the right. And then you can take that value and plug it into your inverse norm to find the Z value. So that gives you a good kind of summary of just chapter 6. There is a lot of information. It seems like it's all different, but it's not. It's just slight modifications on different ideas. What I highly recommend you do, though, is make sure that you're showing work. Yes, you can write down what normal CDFs you're using. I will be able to interpret that and give partial credit as needed.